All right, everyone. So this is the last problem in the set of problems that I started off with. So just as a reminder for us, yeah, it was these first three problems here. Sorry, these three problems. I worked on A and B last video, and now we'll be working on C. All right. So with C here, we're going to use the same idea with the same techniques as we used last time. So the techniques here were, just as a reminder, the first technique was to divide by a power of x raised to a positive exponent. The whole idea behind that was that when you take the limit as x goes to infinity of a number over x together, that equals 0. Well, very similarly, when you go to negative infinity and when you go and divide by x to the r, where r is a positive integer, that goes to 0 as well. So we're gonna do that with this problem. Now, what is it that's the highest quote-unquote power? And that's what we said. Let's divide by what the highest power would be here. And for the numerator, the highest power would be like x, because it's not 2, because you're taking the square root of 2, so it's like, halving it by 1. So it's just x. And for the denominator, it's x as well. That's the only thing we have. So I'm going to divide both the numerator and denominator by x. So once again, you divide by the highest power on both the numerator and the denominator. And you look at each part, and whatever the highest power is, that's what you divide by. When we divide by x, when we divide both the numerator and denominator by x, we are not changing anything in the problem. We're rewriting it, but we're not changing it. All right, so when I divide by x, I'm going to have on the denominator x divided by x. Then I'm going to have square root of x squared plus 1 over x. These cancel, that's just 1, but if you look at what I have, it looks exactly almost the same as to what I originally started off with here, okay? Now, what I'm going to do is, yeah, and seemingly I can't do anything here with, like, in terms of algebra or not. Yeah, there is nothing to do as the way it is right now. So what I'm going to do is as follows. I'm going to try to bring in the x with us inside the square root. So a lot of people say, okay, well, you have a property that says the following, that if you take the square root one thing and divide it by the square root of another thing, it's equal to the square root of the division, the quotient of the two objects inside square root. So we could do that here similarly. But how do we do that with x? Well, you rewrite x with the square root. Well, another way of saying x is the square root of x squared. Almost. The reason this is almost is because of as follows. If you square something and you take the square root, your answer comes out to be positive. Well, we're going to negative infinity. This value, this x that you see, that should be a negative value. But when I rewrote it with that square root, that is now, the output is just positive, the result. So what you do is this, you put a negative in there. And the big picture here is if you want to use this technique that I'm using right here, you have to pay attention to which direction you're headed as a negative infinity or a positive infinity. If it was positive infinity, I wouldn't even care about looking at the negative, but we are going to negative infinity, so that's important because it can change the sign here. Okay, all right. I'm going to rewrite this out now as the square root of x squared plus 1, all with x squared on the inside. So I use that property now. I can rewrite everything with just one square root. And I am going to do this. I'm going to divide each part by x squared because we are allowed to do that. A lot of people ask me when I get to this point, the x squared plus 1 over x squared, do you do the same thing that you would do when you work with those first problems in the first video where you divided both the numerator and denominator by x squared? It's equivalent to what we just did, except that I don't look at it that way because I see it easier just to take each part and divide it by x squared because we have that property of division that allows us to do that, okay? And yeah, so we have negative, the limit as x goes to infinity of negative square root of 1 plus 1 over x squared. And that would equal negative square root of 1 or negative 1 because 1 over x squared goes to 0. All right, so that's how that technique works. Now, the other way to do this, as we did last time, is by looking at the leading term of both the numerator and denominator. And sorry, we're going to negative infinity. And if you look at the leading term of the numerator, that would be the x squared, but that's inside the square root all over x. And what's the square root of x squared? Well, it's not x, it's the absolute value of x, okay? Technically, that's what the square root of x squared is. It's the absolute value of x. And because you're going to negative infinity, the absolute value of x becomes minus x, so it's minus x over x. So by definition, the absolute value of x is equal to two parts. It's equal to x if x is greater than or equal to 0, or it's negative x if x is less than 0. Okay. And so that's what happened here. X became negative x because you're going to negative infinity. And these two cancel out and you just get negative 1. The con of this method, in my opinion, is that you have to know that the square root of x squared is equal to the absolute value of x. It's good to know it, but people forget that all the time. But the other thing here is, yeah, you just have to keep in mind that where you're going. In this case, it's negative infinity, and that's why the absolute value becomes negative x as well. The way to look at it. All right, so this was computing the limit as x goes to negative infinity. So just to recap here real quick, we did it two ways. We divided by the highest power on both the denominator, which was x, and going to what we had here, we wanted to simplify that a little bit more, so I said let's rewrite that as the square root of x squared, because we wanted to get it inside the square root, but the square root of x squared is only positive, but x is actually negative, so we had to put a little negative in the front. And then we used a property which said the square root of a over the square root of b is equal to the square root of a over b. We used that to, and then we simplified the inside of the square root, and we got our limit to be negative 1. And here we used the leading terms, so it was the square root of x squared on the numerator, x on the denominator. The square root of x squared is the absolute value of x, but because you're going to negative infinity, the absolute value becomes negative x. So you have negative x over x, which is negative 1. All right, so I hope this helped. Thank you for your time.